Hey guys, we're going to continue here with Chapter 5, talking about scatter plots and trend lines. Kind of a lot of vocab on this one, so you may want to stretch out your wrist. You're going to be writing a lot. So a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Most scatter plots are in the first quadrant. And then here, scatter plots can help us see trends. When the trends show a relationship, that's called a correlation. We could use these trends to make predictions on things, or we can make inferences, and we have a couple different words that kind of mean that we'll be looking at in just a minute. The correlation thing. All right, so there we go. When y tends to increase as x increases, the two sets of data have what's called a positive correlation. As one value goes up, as y goes up, as x goes up, if they are both going up and it looks in this direction, that's called a positive correlation. When y tends to decrease as x increases, so as x value goes up, this y value is going down, that's called a negative correlation, which is like slope, right? Positive slope as you read left to right goes uphill. Negative slope as you read left to right goes downhill. So this should be somewhat intuitive for you. When x and y do not show any type of relationship, they are plotted all over the place. That's said to have no correlation. All right, and we'll talk about different situations where this arises in just a moment. So make sure you have all this copied down as well as the examples of the different correlations to go along with it. How I feel when I win an argument. A man on a horse on a dirt bike riding a wheelie. That is absolutely true. For me, it's particularly when I win an argument with my wife, because I lose those usually. All right, so making a scatter plot and describing its correlation. The table shows the altitude of an airplane and the temperature outside the plane. It says make a scatter plot of the data. What type of relationship does a scatter plot show? So to make a scatter plot, let's get ourselves a little graph here, a little bit more space. Okay, so I'm going to be graphing this. I'm just going to go up by tens here. So 10, 20, 30. Let's see, where am I? I'm having a hard time seeing the lines. 40, 50, and 60. And this is going to be my temperature. And then down here, I'll put my altitude. In the altitude, I'll start with 0. And I'm going to go up by thousands. So 1,000. We'll say that that's 2,000. This one will be 3,000. 4,000. And I'll put a little line here so that it's clear what goes with what. And it looks like 5,000 is the most, so I'll just stop right there. All right, so I increased by thousands. Let me change colors so it's a little easier for you to see on this white graph. We'll go to the dark blue. That seems to work well. Okay, so when I'm at altitude 0, I'm at temperature 59, which is right about here. At altitude 500, I'm at 59.2, which is going to be right about there. And then here at 61.3, it actually goes up a little bit at 1,000. At 1,500, I got 55.5, so that's going to be roughly here. 2,000 is going to be at 41.6, so I'm starting to drop a little bit here. You can see. And then at 2,500, I get about 29 point, let's see, are my things right? 20, 30, yeah, 40. That's good. 29.8. Start having some big drops in that regard. And then here, 29.9. So that's basically the same at 25 or at 3,000. 3,500. I am down to 18. And you just go through and you plot all these different points. Where am I? 4,000 is 12. Oops, that'd be more like here. And then 4,500 is 12.4, so that's not much of a difference. And I probably made a mistake here because I'm trying to read and do this at the same time. But I think that you for the most part, get the idea. So the question, if I go back, the question said, what type of relationship does a scatter plot show? So here are all my points. The scatter plot, you can see clearly is going downhill. So if it's going downhill, we'd say that that is a negative relationship or a negative correlation. All right, so that's what you need to have copied. As you go left to right, it's going downhill. That's a negative correlation. Here's one for you to try. Go ahead and pause and give that a go. The answer will be up in 3, 2, 1. All right, so here you go. This creates a positive correlation because you see it looks like it, if I were to draw a line that kind of goes through that, which we'll talk about in just a minute, it's going upwards, so that's called a positive correlation. All right, let's keep moving. Trend lines. A trend line is a line on a scatter plot drawn near to the points that it shows a correlation. All right, so here's my scatter plot. If I were to draw a line that best fits in that, that's called a trend line. You can use trend lines to estimate values. When the value is in between two known values, that's called interpolation. Extrapolation is predicting a value outside of the range. So for interpolation, if I were trying to predict a value that's in here, that's called interpolation because it's inside the points. If I were trying to predict a value of something that's way out here, that's outside of the points, and that would be called extrapolation. Okay, so that's what those two terms mean. Okay, so writing an equation of a trend line. It says, make a scatter plot of the data. What is the approximate weight of a 7-month-old panda? So I'm going to skip ahead a little bit and pull up a, okay, so there I already got the scatter plot. Now, in order to find this, I'm going to use a couple points that look like they're pretty much on my, right on my trend line. So this one right here looks like it's on my trend line, and that's at 4. So I got 4 and 17.1. And then another one that looks like, oh, that one looks close enough, so 18 and 37.9. Those are going to be the two values that I'm going to use to find this. Okay, so the first thing to write an equation, okay, so I'm writing an equation of a trend line is, even though it doesn't ask you to, it says it right here, writing an equation. So I'm going to use these 2 points. I need to figure out the slope. Remember, this is x and this is y. So I will do 37.9 minus 17.1 over 8 minus 4. And for that, I get, I'll let you work it all the way out, but I'm just going to cut corners here a little bit. You end up getting approximately 5.2. Okay, so 5.2 is going to be my slope. And then in order to find the full equation, I'm going to use my slope and then one of the points. I'll use that first one and use point slope form. So 5.2 times x minus 4. Distribute all of that. And I get y minus 17.1. It's 5.2x minus 20.8. Add 17 both to both sides. I get y equals 5.2x minus 3.7. And I could check this very, very quickly. So it says my y-intercept's minus 3.7. Well, that makes sense. If I were to continue down here, it looks like it'd be just a little bit negative. And then 5.2, it's positive, and it looks like, yeah, that's probably about what it's increasing. Okay, so there is my equation. After I find the equation based on this line, I can make a prediction of a 7-month-old panda by putting it into this equation. So I'd say y equals 5.2 times 7 minus 3.7. And when I run all that through, I get 32.7. So we guess about 32.7 pounds. You could also use the trend line itself and say, well, here's 7. It's going to be roughly in this area. Okay, right on my trend line. This is going up by, let's see, 12. So that's 6 more, which makes this line a 30. and it's just a tad bit more than 30, which is 32.7. So yeah, based on my trend line, I could believe that that's going to work as well. So that's how you would use a scatter plot and a trend line, and then finding an equation to make a prediction. By the way, this could be interpolation because it's inside the data points. So here's one for you to try. The answer will be up in 3, 2, 1. All right, so here's what I got as my equation. You may not have gotten exactly the same thing as this depending on the points that you use, but I would say that you draw your trend line, you're looking for points that are on it. So if this is the way your trend line goes, I would want to use this point, this point, this point would be fine, this point would be okay. I don't want to use these. Excuse me. Because they're not on my line. I need points that are on the line itself. So any of these would have gotten you something close to this, which would have gotten you something close to this. So that's why this is kind of difficult to grade, because you may not have exactly the same numbers. But as long as yours are pretty close to that, I'm not too concerned. All right, so first thing on this slide, you do not have to copy all of this, just listen. The trend line that shows the relationship between two sets of data is called the line of best fit. A graphing calculator can do this for you. Graphing calculator gives you what's called a correlation coefficient, and down here it says that the nearer to R that is to 1 or to -1, the more closely the data cluster around the line of best fit. We're going to talk about this more in class, but I just want you to see this and know these terms so that you're familiar with it when we do talk. Here's how this plays out. We'll talk about that in class. Causation is when a change in one quantity causes a change in a second quantity. Correlation between quantities does not always imply causation. For instance, the number of loaves of bread baked and the amount of flour used. The more loaves you bake, that means the more flour you would be using. So this one it has a positive correlation, and it is also causation. Okay, they are related to one another. So does this cause it? Is there a causal? So we would say for this, because you need more flours, you'd say yes, there is a causation. Look at this one. The number of mailboxes and the number of firefighters in the city. This would have a positive correlation because the more mailboxes means the more people, and the more people probably means the more firefighters you would need to have to protect that city. But it doesn't cause it. The number of mailboxes doesn't make there be more firefighters in the city. It just means that there probably would be more firefighters in the city. So this would have a positive correlation, but no when it comes to causation. Here's a couple for you to think about. Go ahead and pause and try these. The answers will be up in 3, 2, 1. All right, here. So the cost of a family's vacation, the size of their house. This does not have a causation. It's probably positively correlated. The more expensive somebody's home that they live in, they could probably afford a little bit more of an expensive vacation. But it doesn't necessarily mean that if they live in a large expensive house that they will spend more on a vacation. It doesn't have to be that way. It doesn't cause that. Down here, the time spent exercising and the number of calories burned, yes, that would have a causation because as you exercise more, a result of that is that you burn more calories. So this one does have causation. Hopefully you got that. This one I like. You have to think about these a little bit, and they're not necessarily math related. They're just interesting to think about. So I believe that's it for this lesson. That's kind of a long one. Hopefully you took good notes. We'll probably spend a couple of days working on this stuff in class. I'll see you then.